Find the reference angle for each angle given. So here we have 300 degrees, and 300 degrees is obviously not an acute angle. It's not less than 90 degrees. So all we're going to do to find the reference angle is take this and subtract a half of a revolution of the circle, okay? And that will be, well, that equals 120, okay? That's not an acute angle yet. So now I'm going to take 120 degrees, and I'm going to subtract another half revolution. That gives us negative 60 degrees, all right? Well, negative 60 degrees, while this maybe is not technically an acute angle because it's not between 0 and 90 degrees, it is very easy to see where it is if I were to draw this in standard position. Okay, a negative tells me that I'm going in the opposite direction. I'm going in the clockwise direction, 60 degrees, okay? And obviously that makes a 60-degree angle with the horizontal axis. And so my reference angle is going to be theta prime equals 60 degrees. Okay, a negative 60 degrees makes a 60-degree angle with the horizontal axis. For part B, we have theta equals negative 120 degrees. Well, negative 120 degrees, I can move half of a revolution of a circle by adding, I'm trying to get to an acute angle here, something between 0 and 90 degrees. If I add 180 degrees, half of a revolution, that puts me at 60 degrees. Well, 60 degrees is an acute angle, and so that is my reference angle theta prime. Now this is, I'm going to pause here after these two examples. This is not the only way to find reference angles. If you can draw the angle, if you know where the angle is and you can draw it, then it might be really easy to actually see what the reference angle is. For example, negative 120 degrees, because it's negative, we know we're going in the clockwise direction. Okay, 90 degrees is right there, and we just keep going a little bit. Okay, and it looks like that right there. Well, the reference angle is this angle right here. It's the angle it makes with the with the horizontal axis. And if you remember, of course, you know that half of a revolution is 180 degrees, and we only want 120 of those. We know that we're missing 60 degrees here, so that reference angle would be 60 degrees. Let's go ahead and do this next part, C. We have theta equals 7 pi over 6. This is a radian measurement. So in order to get our reference angle, we're looking for something between 0 and pi over 2 radians. Now, 7 pi over 6 is certainly larger than pi over 2, because 3 pi over 6 would be pi over 2. 3 over 6 is 1/2. So this is larger than an acute angle. So we can find a reference angle by taking, maybe we should stay in black, 7 pi over 6 and subtract half of a revolution around a full circle. Well, half of a revolution is simply pi radians. So now we need to simplify this. We can simplify this by getting a common denominator. Pi is 6 pi over 6. So I have 7 pi over 6 minus 6 pi over 6, which is just 1 pi over 6. Now pi over 6 is an acute angle. It's between 0 and pi over 2. Okay, we could draw that. I'll go ahead and draw it here on this same set of axes. Okay, it's right around there. Okay, that right there is pi over 6. That's going to be our reference angle for 7 pi over 6. Let's look at part D. I'm going to go ahead and approach this one slightly differently so that you can see another approach. Or I'm going to start by trying to sketch this. And I'm just going to, as I reason out drawing where this is, it should lead us right to what the reference angle is. 12 pi over 5. I want to draw where this is. Now, it's important to know some kind of key locations on our plane. We know that one revolution is equal to 2 pi radians. Okay. Now, since I have a fraction here, I have 12 pi over 5, I'm going to go write this in terms of something over 5. Okay. That would be 10 pi over 5. 10 pi over 5. So I know that if I travel one full revolution, okay, I could write that as 10 pi over 5. I'm looking for the angle 12 pi over 5. Well, I can see just looking at this that this is just 2 pi over 5 further than that full revolution. So if I continue 2 pi over 5, okay, well, 2/5 is less than 1/2, and so I know that's less than pi over 2, which is this right angle right here. So I know that that's going to put me somewhere here. And so that angle that I just added, that was 2 pi over 5. And now I can see, oh, that is the reference angle for my angle. Okay, 12 pi over 5 goes all the way around and then keeps going and hits this same terminal side. Okay, the reference angle is just the angle that makes with the horizontal axis, the acute angle. And so that's going to be this 2 pi over 5. So for this one, my reference angle theta prime is 2 pi over 5.